Alright, in this lesson we are going to review the rules for simplifying expressions with exponents, okay? And there are several properties of exponents and we are just going to practice those. So first is the product of powers property, and basically the shortcut is if you have variables with the same base, and when I'm using this word base, you know, we've got a base and then we've got an exponent or power. So this is the base, that's the power. So see how in this case the a's are the bases and they're the same. In that case, if you want to multiply, you will add those exponents. So if I have x to the 5th power times x to the 7th power, that's going to give me x to the 12th power. Now, I'm going to show you several of these properties, and it's easy to get them confused. So I think it's beneficial to keep in your mind where these rules are actually coming from. So let me just take 1 second and remind you. If you have x to the 5th power, what does that really mean? Right? Anything to a power, like x to the 5th power, you understand that that really means x times x times x times x times x. Alright? It's 5x's all multiplied together. But then, if I have x to the 7th power, what does that mean? 1, 2, 3, 4, 5, 6, 7. So x to the 5th power times x to the 7th power, if you put that together, that really means 5x's all multiplied together times 7x's all multiplied together. So obviously, if I gave you all this and I told you to write that in a simpler way, you would look at all these x's being multiplied together, you'd count them all up, and you'd find out that there were 5 and 7, there are 12 of them. So that is why this makes x to the 12th power. So yes, I want you to use the shortcuts, and I want you to understand that when you have the same bases multiplying, you just add. But what if you forget? Understanding what's happening behind the scenes will help you remember. Okay, so that's a lot of dots. So same thing with problem number 2. Alright, so that was x to the 12th power. Looking at problem number 2, you could put this all in your calculator, but that's not what you're supposed to do. This is 4 to the 4th power, 4 to the 7th power. By adding these exponents, I will get 4 to the 11th power. And you can just leave your answer like that. But please just understand, some kids think that this will be, alright, let me put this in green because this is wrong, what I'm about to say. This is about to be a no. A common mistake is kids will do 16 to the 11th power, thinking that they're going to do 4 times 4. Well, no, you don't do 16, okay? You don't just multiply 4 times 4. You keep the 4 and add the 4 and the 7 makes 11. Alright, one more time. I think it might help you understand that if you understand that 4 to the 4th power means 4 times 4 times 4 times 4. Okay? And then 4 to the 7th power means 1, 2, 3, 4, 5, 6, 7. So when you put all these together, 4 times itself, again there are 11 of them, but they are still 4s. They're not suddenly 16s. So it makes sense that it would just be 4 to the 11th power, not 16 to the 11th power. Alright, so knowing what goes on behind the scenes will help you know what to do. If for some reason your teacher does want a big old number, you can put this in your calculator. Alright, 4, use the caret there to the 11th power. This is this actual number. Okay, But for me, I would let you just leave it as 4 to the 11th power. Now, look at number 3. Same process, it's just sort of we are grouping the things that go together. So if we have x to the 5th power times x to the 8th power, what is that going to make? That's going to make x to the 13th power. All right, again, we're just adding those exponents just like we did on the previous 2 problems. And then looking at the y's, all right, we've got this y to the 3rd power and we've got y squared. If we put those together, what's that going to make? That's going to make y to the 5th power. All right, so that would be your answer for number 3. All right, let's move on to the next property. Power of a power property. When a power is raised to another power, you multiply the exponent. So notice on the previous property, the base appears twice. I have a, and then I have another a, and then I wind up adding. Notice for this property, the base only appears once. I just have the one a, and then I have a power, and then another power. So when that happens, you multiply the 2 powers together. So power raised to a power, that's when you multiply. So as far as using our little shortcut then, this is going to be x to the 15th power. All right, you just simply multiply these when you have it like that. Now, one more time, I'm going to do this the long way, just so you can understand that if you ever forget the rule, doing a simple problem out the long way will help you remember. Now, first of all, let's start with the 5th power. If you do anything to the 5th power, you understand that that means doing it 5 times. So I have parentheses to the 5th power. So that means I'm going to do this parentheses 5 times. 1, 2, 3, 4, 5. So this is me doing the 5th power. Now what is in this parentheses? It is x to the 3rd power. So it's like I have x to the 3rd power times itself 5 times. I've got my parentheses 5 times. Okay? But if I go down that one further level, what is x to the 3rd power? Well, that's x times x times x. X times x times x. Again and again and again. Again and again and again. Again and again and again. All right, and if I multiply all this together, you will see we're back to just like we were doing before. At the end of the day, you're counting up how many of these things you really have. So I have x times x times x, but I have, if I add them all up, it's going to be 15. All right, I have 5 groups of 3. That's 15. So that is really how I know it is the 15th power. Now obviously you do not want to go through this process, you just want to do 3 times 5. But if you forget, like, wait a minute, is this the one where I add or is this one where I multiply? If you have the ability to go back and work it out the long way, it will quickly remind you of the rule. Okay? Let me erase this. Okay. Power to a power, I multiply. So this is just going to be 2 to the 18th power. And I would just leave it like that. All right? Obviously, you could put it in your calculator, 2 caret 18. And, you know, if your teacher wants a big, giant number, that's what it would be. But for me, leave it like that. Now, okay, I'm going to have to be careful a little bit here because I see I've got the negative sign in there. Understand this, guys. If I square something that's negative, that's going to wind up being a positive number. Do you understand that? If I have negative 4 squared, that means negative 4 times negative 4. And so you know that would be a positive 16. So please keep that in the back of your mind. So whatever happens, my result is going to be positive because I'm squaring it. That negative is going to go away. Now, so if I kind of ignore the negative sign now because I know that it's going to go away, now I can go ahead and do my the other part of my rule. So power to a power, I multiply these. So this is going to be 4 to the 4th power. Okay? And if you wanted a numerical answer, okay, that would wind up being 256. All right, but again, please notice it is a positive 256. For the record, if you are using a TI-30XS multiview, and if your teacher was nice enough or foolish enough to let you use your calculator, please understand you could type this entire thing in your calculator. Okay, you could do the whole thing. -4 squared squared. Okay? And boom, it's going to give you the 256. Positive 256. So just be aware of what your calculator can do. But for now, let's move on to the next property. Product to a power. Okay? In a situation like this, if I have more than one thing inside the parentheses being raised to the power, all I'm really doing is this is really not a different property than what we had before. If I have something in the parentheses with a power on it and then I raise it to a power, you know I multiply. Okay? So that's same thing is going to still apply no matter how many things I have in here. So I'm still going to multiply. I'm going to still multiply the 3 times the 2, and I'm still going to multiply the 3 times the 3. Alright, it's really not a different rule. So this is going to wind up being x to the 6th power times y to the 9th power. Alright, it's really the same property as before. Okay, but here's where you have to be careful. This 2 is not a variable. It's a constant. Okay? So when I'm doing all this multiplication business, that only applies to exponents. Alright? So, by the way, let me zoom in. Look at this x. What is the exponent of the x? Well, you could think of it as a 1 if it helps you. So when I do the x to the 1st power and the y to the 6th power to a power of 7, well, yes, once again, a power raised to a power, you multiply. So this is going to wind up being x to the 7th power and y to the 42 power. All right, because 6 times 7 is 42. But the 2, I will not repeat. I will not multiply 2 times 7. Right? Because this 2 is not an exponent. It's not a variable and a power. I still have to do 2 to the 7th power. Okay? Like, think of it this way. If I erased the x's and y's, all right? If I took these x's and y's and scribbled them out, all right? What I would be left with is 2 to the 7th power. And it would look like this, 2 to the 7th power. All right, so let's go ahead and get an answer for that. So 2 to the 7th power is 128. So I would go ahead and put 128 x to the 7th power, y to the 42 power. Kabam! All right, now number 9. So let's do these as like they were 2 problems separately. So let's start with this problem. Well, remember this is like a 1 and a 1, and it's like you're multiplying. So this will be x to the 3rd power, y to the 3rd power. All right. Now let's do this problem separately. Okay, so this will be z to the 10th power, because I'm just going to multiply those. And then that's my answer. All right, pretty easy stuff. Okay, now the last property I want to mention is the quotient of powers. Now, quotient means division. And it turns out that if you have the same base like this and you're dividing, you can simplify by subtracting the numerator exponent minus the denominator's exponent. Okay, so just like this. So looking at problem number 10, this would be the same thing as having x to the 5 minus 3 power. Okay, but that's going to give me x squared. So that is going to be my final answer. Now, again, I'm going to take this opportunity to show you what's really happening behind the scenes. Yes, I want you to understand that it is subtraction, 5 minus 3, and that's a shortcut. But one time, let me show you what's really happening, because every now and then, understanding what's happening behind the scenes will help you as things get more confusing. X to the 5th power is really x times times x times x. There's my x to the 5th power. X to the 3rd power is x times x times x. Well, you know what happens when you have the same things in the numerator and the denominator. You can just cancel those things out. So these three x's are really dividing each other away. And that leaves these two x's. So that's where the x squared is truly coming from. Okay? Look at number 11. Now really, okay, on this problem, I really want you to think of this sort of the way I showed it behind the scenes, okay? 3 squared, let's break this down. All right, now you can do this in your head, but this is what I want you to be thinking. 3 squared is 3 times 3, okay? X squared is x times x. Y to the 4th power is y times y times y times y. Now in the denominator, I've got this 3, and then I've got x to the 5th power, 1, 2, 3, 4, 5. And then I've got y squared, y. So I think you will be better off thinking of it this way. So what happens with these 3's? Well, these 3's cancel each other out. What happens with the x's? Well, the 2 x's in the numerator will cancel out 2 of the x's in the denominator. Alright, that's going to leave these 3 x's. What happens with the y's? Well, these 2 y's are going to cancel out 2 of these y's. So pay attention to what's left and where. So here's what's left. In the numerator, I've got this 3 and the 2 y's. Alright, obviously that's y squared. In the denominator, I've got these 3 x's. So in other words, what's left is 3 y squared over x to the 3rd power. So that is your answer. Okay, I think this is easier than actually trying to subtract. Because if you do 2 minus 5, you're going to get negative 3. Now I know that that means it's going to go on the denominator. But many students get confused and they don't know what goes on the top, what goes on the bottom. If you think of it as canceling things out, it becomes obvious to you. Where are there more x's? Are there more x's on the top or the bottom? Well, look, there's 5 x's on the bottom. That's more. So the extra x's will be on the bottom when all the dust clears. Look at the y's. Where are there more y's? There are more y's in the top. That's why the extra y's end up in the top. Okay, look at number 12. Just at a glance, where will the extra x's be? In the top or the bottom? They'll be in the top. Where will the extra y's be? They will be in the bottom because that's where there are more. So if you understand that, then you can kind of do your shortcuts again. Okay, so you should be able to glance at this and go, okay, there's 2 x's in the top, 1 in the bottom. So I'm going to subtract this 1x, okay, if you will, away from the 2 x's. So that's going to leave 1x on the top. There's 7 y's on the top, there's 10 y's in the bottom. Alright, so you can think of it as subtracting, alright, 7 minus 10. But those 3 y's that are left over will be on the bottom because that's where the extras are. So the final answer should be x over y to the 3rd power. And again, when in doubt, just write it out the long way if you can. Alright, x squared, that's xx. And then we had the 1x here in the bottom. Alright, and then the y's, y to the 7th, 1, 2, 3, 4, 5, 6, 7. And then y to the 10th, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So what happens? This 1x cancels out one of these x's. Alright, leaving 1x behind. These 7 y's cancel out 1, 2, 3, 4, 5, 6, 7 y's, leaving 3 y's on the bottom. And that is how we get 1x in the top, 3 y's on the bottom. All right. Okay. So now, a few more powers. Let me pick up the pace a little bit. Now, if I have the power of a quotient, I'm just going to wind up doing that power to the numerator and the denominator. Bam, bam. Okay? So, in this case, I'm going to take this power of 3, and I'm going to wind up doing it to the numerator and the denominator. So, in this case, I'm going to wind up with x to the 6th power. Okay, because of a power raised to a power, just like we saw above, if you have a power raised to another power, you multiply. So that's all we're doing. Okay, but be aware, when I go back and do the power to the 5, I will not multiply. I'm not going to get 15. If I have an actual number and a power, I have to do that power. I have to do 5 to the 3rd power. So this is going to make, alright, so I have x to the 6th power. 5 to the 3rd power turns out to be 125. So this is the answer, number 13. Okay, power to a power, that's going to give me a to the 12th power. You just multiply those. And then do it again. Alright, if I do a power to a power, I multiply. So that's going to give me b to the 8th power. That's it. Nothing more I can do with that. I know you like that rectangle. Okay. Number 15. Now, the thing that's different about number 15 is there are things that we can simplify inside the parentheses. If I look back here, I had a's and b's. There's nothing that can cancel out. So if I were you, I would simplify whatever I can on the inside first. So I'm going to leave this as the 3rd power. Now what's going to happen with these x's? Alright, these 5 x's are going to cancel out 5 of these x's. And it's going to leave behind 2 x's in the top. How do I know they'll be in the top? Because that's where there are more x's. Alright, there's 7 of them. Here there's only 5. This is more. Now let's look at the y's. Y to the 3rd power and y. Well, this 1y is going to cancel out one of these y's. So that's just going to leave behind 2y's, or y squared. So now that I look at it, I'm not going to actually need this fraction line here. So this is all I have left. So now if I go ahead and do the power to a power rule, I'm going to multiply, but it's just these two things. So this is going to give me x to the 6th power and y to the 6th power. So that is going to be the answer to number 15. Okay, what is next? Alright, last but not least, we have the negative power rule. If you have a base with a negative power, that negative power means that that base is on the wrong side of the fraction. So if it's written like this, I will just drop it down to the denominator, drop it down to the bottom, and notice once I make that change, the exponent is now positive. Okay, so that means that this one is going to become 1 over 5 to the 3rd power, just straight following this pattern. Okay, it just simply goes to the bottom. But I'm going to go ahead and do this. 5 to the 3rd powers is not an overwhelmingly big number, so that is 125 as previously discussed. So that would be the answer to number 16. Look, for the record, yeah, your calculator will do this. If I do 5 caret negative 3, that's my 5 to the negative 3 power, your calculator understands that that is 1 over 125. If you have a TI-30XS multi-view, which I highly recommend. Why am I looking at that? Okay, number 17. Now, this I have to think a little bit because I have negative exponents in the numerator and denominator. Lean closer. Listen to me. If you have negative exponents, the way I think of it is these expressions are on the wrong side of the fraction. Anything that has a negative exponent. So because this has a negative exponent, that means it has to go down to the denominator. Okay, because this one has a negative exponent and it's already on the denominator, that means it has to go up. Alright, so anything with a negative exponent gets moved. So what I'm going to end up with is x squared and in the top and next to the 5th power in the bottom. Notice that once I move these things that have a negative exponent, then the exponent becomes positive. Otherwise, I'd have to move it again, and I'd just keep moving it and moving it and moving it. The rest we can do like we've always done in the previous problems. I have 2 x's in the bottom, 2 x's in the top, 5 x's in the bottom. These 2 x's are going to cancel out 2 of these x's. That's going to leave behind 3 x's. So x to the 3rd power. There will be no x's left in the top. I cannot just write x to the 3rd power. It has to be in the denominator because that's where the extra x's are. So I need this sort of a placeholder, alright, which makes sense because remember, when I'm canceling things out, I'm really dividing, and anything divided by itself is 1. Okay, every time I cancel, I'm really making 1. So it makes sense that this would be a 1. Okay, is this the last problem? Alright, I think this is the last problem. Alright, this should be its own property. Okay, I'm going to write it, I'm going to make a new property. This is the Burton property. If I have a over b, okay, and then I have the negative n power, this is going to be the same thing as b over a to the positive n power. Do you understand what I'm saying? So if you have a negative power on a fraction, I want you to turn that fraction upside down, and then the exponent will be positive. Okay, so keep that in mind. Here again, I still would simplify whatever's on the inside first. Simplify this mess, okay? So for a minute, I'm going to leave this as negative 2 power. I will do this whole reciprocal business later. Okay, so look what happens. I have 2 x's in the top, 5 in the bottom. That's going to leave me with 3 x's in the bottom and none in the top. Now here I have 1 3 in the top. Okay, look, this is like, I feel like I need to write this out. This is what's happening. I have 3, then I had x, and I have 3 squared. That's 3 times 3, and then 1, 2, 3, 4, 5. So yeah, like I said, these 2 x's will take out these 2 x's. So I've got 3 left. Okay, that's that. Now, this 3 will cancel out the 3 in the bottom, but that still leaves one of them. Alright, so I'm going to have a 3 in the bottom. Again, these have to be in the denominator. So what do I put up here? Put a 1 up there. Alright, I always recommend simplifying the inside part first. Now, what did I just tell you to do when you have a fraction and a negative power? Yes, I told you to do the reciprocal. So this would be like 3x to the 3rd power over 1. And then with a positive 2 power. Once you do the reciprocal, it becomes positive. Now, did I really need to put the 1 down here? No, the 1 is necessary when it's in the numerator. In the denominator, it's going to bring this over a bit. In the denominator, this will not be necessary. So I will have 3x to the 3rd power squared. You really didn't have to write the 1. And so now I will go ahead and do the powers. So what will happen to this 3? Is this going to be a 3 times 2? Will I get 6? No, I will not. Okay, remember, if I were to erase this, what I have here is 3 squared. What is 3 squared? It is 9. So this is going to wind up being 9, not 6. Okay, let me bring that back. Alright, so I'm going to have 9. Now, when I do this part, though, this is that power to a power. This is when you multiply. 3 times 2 is 6, so I'll have x to the 6th power. One more time, notice the difference. If you have a regular number, you have to actually do the power like 3 squared. You do not multiply. You only multiply when you have an exponent and another exponent. Okay? Another way to look at this is the long way. Let me show this the long way. This is the last problem, so let's do it up. Anything squared means that thing times itself. So parentheses squared means parentheses times parentheses. What's in the parentheses? 3x to the 3rd power. So I've got 3x to the 3rd power times 3x to the 3rd power. If you look at it this way, it makes sense that I'm going to have 9, because it's really 3 times 3, and that's what's giving me the 9. Okay, so I've really got 3xxx times 3xxx. Alright, so if you put it all together, you've got 3 times 3 times x times x times x times x times x times x. Okay, so that's why 3 times 3 is 9. If you put all those x's together, you have 6 of them. Okay, now it's much shorter just to do it from here. Oh, this is 3 squared. Oh, this is x to the 6th power, because I multiply. Yes, use the shortcuts, but understand why the shortcuts really work. And that is the end of this lesson. That is our review of how exponents work. I hope this has been somewhat helpful to you. And if it has been helpful, a like is always appreciated. I will see you on the next video.